Okay, what we're going to do today, our goal is to determine whether word problems are you're finding the greatest common factor or least common multiple. This is a review from what we started yesterday in remote learning. We're going to go over a couple more problems. Then we're going to get started on the distributive property. Raise your hand if you ever heard of the distributive property. Me personally, I think the distributive property is fun in a math way, okay, to do. There's a lot of different things you can work through to simplify and make your a big problem smaller. Okay? So I find it something entertaining to do. Hopefully, same for you. The first thing I want to do, we're going to complete your daily review. Let's go over the two questions because I did have quite a few people who missed them. There's some important information that I can help explain. So, question number 1. It says, what is the ordered pair of 5, -7 if it was reflected across the y-axis? So if we reflect across the y-axis, what do you know is going to be true? Sam? Good, the y stays the same. So if I rewrite my ordered pair, I have always x comma y. And then we have, so we know our y is staying the same. So the second number is -7. What's true about the other number? Maddie?
It goes from a positive to negative.
Okay, in this case that is true. That's not always the case. So what can you say to make it always be true? Sydney? Good, it becomes its opposite. So the 5 becomes -5. So the answer was B there. So after I taught this to your class, I came up with a song to help remember this. Do you want to hear my song?
Yes. Oh. Yes.
Okay. All right. I'll share it with you. You ready? Reflect across the x stays the same. Reflect across the y stays the same. Reflect across the x stays the same. Reflect across the y stays the same.
You should become a It's not a song.
What do you think? Rap, yeah.
You should become a musician. Brandon,
You want to join me now?
No.
No one wants to join me?
No. Thank you.
All right. Okay. Well, that is one way to help you remember when reflecting across the x. Your x will always stay the same. The y becomes its opposite. When you reflect across the y-axis, the y is going to stay the same. All right. I guess I'll just stay a teacher instead of becoming a musician. All right. Now, evaluate the following expression. 4 8/10 divided by 0 8/10. Okay. So writing this problem out, we need to do long division. What number is going to go inside the house? Jordan?
4.8.
Good. 4 8/10. Some people maybe we forget going back to our fractions, how we build a house, the 2 falls in. If you were writing a fraction with the division set up like this, it would be 2 divided by 7. So the first number always goes inside the house. 0, 8, outside. All right. So, what is our next step? Alex. Oh. Ooh. This is the first class today that's actually said it right. Thank you. Did you hear from a different class that we had to do the swoop song? No. So many people today have been saying the other word starts with an M. I don't want to say it, but that's what they've been saying. So thank you, Alex, for giving us the correct terminology. We need to swoop the decimal point over 1 time to make it a whole number. Whatever you do to the outside, you must do to the inside. So we swoop it 1 time. So you can rewrite the problem, and I think it's easier to do that. It's now 48 divided by 8. What is the answer? 48 divided by 8. Sydney? 6. It is 6. Is anyone okay with raising their hand and saying, I put 0 and 6/10? I had a lot of people who do that today. They actually probably have more people put 0 and 6/10 rather than 6 so far today. To me, that just means that you did not show your work and you just thought, oh, it's 6/10 because that's 4 and 8/10, and that other one is 8/10. All right. So please show the work. Swoop your decimal points so you have whole numbers on the outside. Is everyone good with that? All right. Okay, what we are going to do now is, here are some, let's start with question number 5, word problem of GCF and LCM. When given a word problem, the hardest thing is decide, is it GCF or is it LCM? The best thing I can tell you to do is either before you're solving it or after you solve it, should my answer be larger than the numbers I'm comparing, or should it be smaller than the numbers I'm comparing? Okay. If your answer should be greater than the numbers you're comparing, what method will you do? Or what will you be finding out? GCF or LCM? If it's getting greater, Liam? It would be LCM. If your number should be smaller, you'll be finding, Caden? You'll be finding the GCF. That's probably one of the best ways I can help you decide in a word problem. So at this time, go ahead and answer question number 5. All right, question number 5 says, 2 neon lights are turned on at the same time. One blinks every 4 seconds and the other blinks every 6 seconds. In 60 seconds, how many times will they blink at the same time? So we need to figure out how many times or at what second are they blinking at the same time. So are we finding the GCF or LCM here? Should our answers be greater or less than 4 and 6? Maddie?
LCM.
Good. We are finding the LCM. I'm going to use ladder method to explain how to find LCM. Write the two numbers, create my ladder. What can I divide out of 6 and 4? Alex? 2. That gives me 3 and 2. Can I divide anything else out of 3 and 2 other than 1? No. So I stop there. Where is the LCM in the ladder method? Paige. Perfect. All the numbers on the outside. It creates an L, a sock, a shoe, whatever you would like to think, but it's everything on the outside. 2 times 3 is 6, times 2 is 12. That means every 12 seconds, both of these neon lights blink at the same time. So, how many times will they blink at the same time? Or, how many times in 60 seconds will they blink at the same time? Audrey? 5. Perfect. 5 times. 5 times they will blink at the same time in 60 seconds. Does everyone see how we got that? It's every 12 seconds. So we need to figure out how many 12 seconds are in 60 seconds, which is 5. All right. Nice job. Let's go ahead and question number 6. Go ahead and try question number 6. All right, question number 6 says, the table shows the number of students in the school choir. There are 48 girls and 64 boys. The choir teacher plans to arrange the students in equal rows. Only girls or boys will be in each row. What is the greatest number of students that could be in each row? So again, ask yourself.
This includes fourth period lunch.
So are we looking for a number that's going to be greater than 48 and 64, or a number that's less than 48 and 64? Alex?
Less.
It's less than, right? We're not going to have more people in a row than what we have. Right? That does not make sense. Okay, so again, look at your answer when you do that, or just think about the process. Does that answer make sense? So we are finding the, all together?
GCF.
Good. Greatest common factor, or GCF. 48 and 64. Again, I'm going to use the ladder method. What numbers can I divide out of 48 and 64? Sam, you can divide 8 out. You get 6 and 8. Can I divide anything else out of 6 and 8? You can divide 2 out. So I add another step to my ladder. I get 3 and 4. Can I divide anything else out of 3 and 4? Nope. 1, but it does not do us any good. So where is your answer for the ladder method for GCF? Annabella. Good. It's everything on the left side. There's more than one number. You multiply them. That means we have 16 students in each row. Okay. You ready for this? How many rows will we have? The choir teacher will have how many rows? Samantha, what do you think? 12. Okay, anyone else? Kaden? 7. Emery? 14. 16. 7. I agree with 7. 7 is the correct answer of how many rows this choir will have. If you have 16 people in each row, there are 48 girls. What is 48 divided by 16? 3. You have 64 boys. You're going to put them in rows of 16. How many rows would you have of boys? Sam? 4. So we will have a total of 7 rows. Okay? When you do the ladder method, these bottom numbers usually help you solve problems. Good with that? One last one, real quick. Question number 8. Go ahead and solve question 8. All right, Bridget has swimming lessons every 5th day and diving lessons every 3rd day. And she had a swimming lesson and diving lesson on May 5th. When will be the next time she has both swimming and diving lessons? Are we finding the GCF or LCM here? Jack?
GCF.
Okay, so our number is going to be smaller. Okay, Sam, what do you think? LCM. Why do you think it's LCM over GCF?
Because 5 and 3 don't have any factors that are common.
Good. Okay, they do. They have 1, which should be common, but that means every day they have the same one. Does that make sense? If they have every day they have swim and dive, that's not true because it says they have it every 5th day and every 3rd day. So we were going to look past the 5th and 3rd day to see which ones they would go at the same time. So using the ladder method, we have 5 and 3. What can you divide out of 5 and 3? Kale? 1, right? You can't put a 1 here and put 5 and 3. This is Nicholas, get away. Okay? But we don't have to. I would just, there's a 1, I wouldn't do anything, and I would just multiply 5 times 3 to get 15. Right? Be lazy if you want, and don't write the 1. Because when you multiply by 1, it doesn't do anything for you. So, on what, if we know that every 15th day they have both lessons, what date will they have both of them? Jack? Good. May 20th, they will have both. Okay, we're going to go ahead and move on to the distributive property. Okay, stop me at 10:53. because I really enjoy talking about this, but I want to give you time to start your homework. Okay? All right. So, if I give you the problem 5 parentheses 2 plus 3, how would you solve this problem based on what we've learned so far? Emery.
You would do the parentheses first and then multiply the product of 2 and 3 by 5.
Nice. I like how you use the word product there. We would add these first to get 5, and then become 5 times 5, which is 25. This is what you know. It's using the order of operations. Distributive property is a little different, and it is set up the same way. We have the problem 5 times parentheses 2 plus 3. The distributive property says we are not going to do what's in the parentheses first. We are going to take the number on the outside, and we're going to distribute it to everything on the inside. Okay, so what would the operation of 5 and 2 be here, you think? Liam? 5
times 2.
Perfect. It would be multiplication because this is a 5 parentheses, so it's multiplication. So it's 5 times 2. Then I'm going to distribute the 5 to the 3. What operation do you think is going to be between those two? Jordan? Good, multiplication, 5 times 3. What operation is going to be in between these two now? Lila? Addition, because there's addition right here. What is 5 times 2 altogether? 10 plus, what's 5 times 3? 15. You get an answer of 25. It's the same thing, you get the same answer. Okay, when you hear the word distributive, what do you think of? Man. Good. Giving something out. You distribute. You pass things out. Would you agree? When you pass out cards, you distribute the cards. Who distributes things around this time of the year? Who distributes things? Kagan. Santa Claus. Absolutely. So, when you think of Santa Claus, I'm going to show you. Santa Claus and distributed property have something in common. What did I just create? Santa's hat. Here is Santa's hat. Here is the big part that goes around your head. Here is the red part that goes all the way around. And here is the white ball at the end. There is Santa's hat. Santa distributes presents to distribute property. You distribute everything on the outside to everything on the inside. Okay? This is the distributed property of addition. I want to show you the distributed property of subtraction, and then you will. So if I have 4 parentheses 7 minus 2, using the order of operations, what would I do first over here? Sam?
7 minus 2.
And now we get 5. 5 times 4 is 20. Distributed property, what would I do first? Jordan?
4 times 7.
Good. Distribute the 4 to the 7. That's 4 times 7. Distribute the 4 to the 2. 4 times 2. What operation is going to go in between these two multiplication problems? Samantha? Subtraction, because we have subtraction up here. Good job. 4 times 7 is 28, minus 4 times 2, which is 8. 28 minus 8 is 20. I have 1 more minute. All right, so there's just adding and subtracting. What I want to talk to you about, though, is, well, why wouldn't we just do the order of operations? If I give you 5x plus 2, can we do x plus 2? No. So we use the distributive property to simplify. 5 gets distributed to the x. How do you think we'd write that? Kaden? 5 times x, or even lazier, 5x. All right? And then my 5 gets distributed to 2. Please don't look at the clock. I will give you time. Okay? 5 gets distributed to 2. That's so 5 times 2. What operation is going to go in between? Addition. Can I simplify this anymore? Yes, what can I do? There's another part of this that I can solve. Jordan. Well, the variable, we can't take 5 times anything because we don't know what that x is. Okay? Okay? You do 5 times 2. So this simplified is 5x plus 10. This is the simplest form of that. This is just simplified. This is not going to be 15x. Please do not think of that. Because we have to multiply before we add. All right, I'm stopping. Go ahead.